Hello, Math 150. We're looking at section 3.2, and we're going to be doing learning objectives 3 and 4 in this section. The first one is to use the rational zeros theorem to list the potential rational zeros, okay? You look at this box right here, and this is what you're going to find in your textbook, and there's a lot going on there. I'm going to try to simplify this down for you. Here's the deal. We're going to play a really sophisticated game of guess and check today, and the way it's going to work is we're going to try to guess what the solutions and the zeros are for these functions, these polynomials. So the idea is if you boil it all down, if there is a real zero, the numerator must be a factor of the constant term, and the denominator must be a factor of the leading coefficient. So when we're making our guess as to what the zeros will be, we're going to look at the leading term and the constant term, and we're just going to make fractions out of their factors. Let's look at an example so you can see it in practice. That will make it a little bit easier for you to think about. In this example, what's going on is we are looking for the factors of the constant term. And that constant term is 12. So we're talking about the factors of 12 to start with. So that's going to be plus or minus 1, and they're all going to have plus or minus on them. So it's going to be the ones. When I say the ones with plural, I mean the plus or minus. The 2s, the 3s, the 4s, the 6s, and the 12. So there's quite a few for the factors of 12. But now we're going to look at the factors of the leading coefficient, which is always the one with the highest degree. So that's 2 in this case. So for this one, we're just going to get the plus or minus 1s and the 2s. Our potential zeros, are going to be found by basically taking all of these numbers and putting them at the top of a fraction and all the combinations with these numbers in the bottom of the fraction. So the first one I'm going to do, I'm literally just going to take this one right here. I'm going to copy this, paste it right there, and then I'm going to go and I'm going to make a fraction over this guy. So there we go. That would be our first one, okay? Our second one would be if we took this one over this one, the 2s over the 1s, then the 3s over the 1s, then the 4s over the 1s, excuse me, and so on and so forth, all the way down the line. So I'm just going to start simplifying these as we go along. So the first one were the 1s over the 1s. When you do all those combinations out, you're going to find out that the only two results you can get are plus or minus 1. The next one I'm going to do are the 2s over the 1s. That's going to give us a result of plus or minus 2s. Then the 3s over the 1s, plus or minus 3s. The 4s over the 1s are going to give us plus or minus 4s. And we're going to continue right down the line until we get the 6s over the 1s and the 12s over the 1s, which will give us plus or minus 6 and plus or minus 12. So those are potential factors. We now have to do all of the top numbers over the second one to get all the different combinations. So the first one we're going to say is the plus or minus 1s over the plus or minus 2s. That's going to result in plus or minus 1/2. Then we're going to do plus or minus 2s over the plus or minus 2s. Well, that's going to reduce down to our plus or minus 1, so we forget that. So now our plus or minus 3s over our plus or minus 2s. So the 3s over the 2s are going to result in plus or minus 3/2. As you keep looking, the rest of these are even. When I put them over 2, they're going to simplify. The 4 over 2 is going to give me the 2s. The 6s over 2 is going to give me 3s. And the 12 over 2 is going to give me 6s. We already have those listed. So again, the idea is to find all the factors of the constant term and do all the combinations of the factors over the leading term. Those are going to give us your potential solutions. So these are the potential solutions for zeros for this polynomial. Okay, so there they go. Those are our potential solutions. So now we're going to take this and put it into practice and try to find the actual zeros. Okay, now this is going to require some work, some guess and check, but we're going to do it. So the second objective for this one, this video, is to find the real zeros of polynomial functions. That's your learning objective 4. Here are the steps. The first one is to use the degree of the polynomial to determine the maximum number. We talked about this in an earlier video. When we've got degree 4, what that's telling us is the maximum number of solutions, maximum number of zeros is 4. So we can have less than 4, but we can't have more than 4. So that's step 1. Step 2 is to use Descartes' rule of signs to find out whether or not we're going to have how many positive solutions and how many negative solutions we can have. So you may remember from our last video, Descartes' rule of signs. We're going to go and we're going to count the sign changes. So this term is positive, next one's negative, then positive, then positive. So as we count the sign changes, what we're going to see is that we're going to get a total of 2 sign changes. So there are 2 or 0 positive roots in this problem, or zeros. Positive roots or zeros, same thing. Okay. So now when we go and we put in the negative x, this will be next to the 4th. We'll lose the sign. This will keep the sign. This, since it's an even exponent, will lose the sign. This will keep the sign. So now let's put the coefficients in there. We're going to end up with 2x to the 4th. We're going to end up with minus x to the 3rd. Here we've got a negative 11 times that x squared. That's going to be negative 11x squared. Here it's a positive 4 and a negative x. That's going to be negative 4x. And last is 12. So we have a positive, negative, 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 positive. That was a 12. Count the sign changes. So we're seeing that this one only, this one has 2 total sign changes. So there will be 2 or 0 negative roots or zeros. Now that makes a little bit of sense. We knew the maximum number we could have was 4. So if we had 2 here and 2 here, that would give us our maximum number. So from here, we've actually now going to start the guess and check process. So I am going to use our property that says plug in one of the values, and if f of c is equal to 0, that means that x minus c is a factor. So we're going to test this, okay? That comes from one of the earlier videos we did in this section. So the first number I'm going to test is f of positive 1. So if this equals 0, we know we've got a factor. So when I use f of 1, I'm going to get 2 minus 1 minus 11 plus 4 plus 12. And again, I'm just plugging 1 into this expression right here. When I work that all out, I end up with, let's see, right there, that is a negative 12 and a positive 12. Those cancel, but I'm left with 6. So I know that 1 does not give me a 0. Okay, so we're crossing out positive 1. I'm now going to go to negative 1. I'm just going to work my way right down the line here until I find one that works. So doing negative 1 and plugging that in, that's going to be 2 when I plug in negative 1 into the first term. It's going to be positive 1 when I plug it into the second term. It's going to be negative 11 when I plug it into the third. It's going to be negative 4 when I plug it into the fourth. And it's going to be positive 12 when I plug it into the fifth. So we're going to do a little bit of work here. We're going to find out that here we have negative 15. But when we combine these terms, I have positive 15. Hey, we're in luck. We know that f of negative 1 equals 0. That implies that the factor is x plus 1. Okay, again, it's kind of the reverse of the sign, because we know that we need to plug negative 1 into our factor to make 0. So when negative 1 works, x plus 1 is a 0. So now I know I've got one factor. So what I'd like to do now is take advantage of synthetic division to see if I can find the other factor. So I know that negative 1 is a 0. I know my coefficients are 2, negative 1, negative 11, positive 4, and 12. And I want to see if when we divide this out, we should actually get a 0 remainder. So let's check that out, okay? So here we go. Negative 1 times 2 is negative 2. Add those gives me negative 3. Now I'm going to do the negative 1 times my negative 3. That's going to get me positive 3. And when I add this column, I get negative 8. Now I'm going to do the negative 1 times the negative 8. So when I do that, that gets me positive 8. And when I add that column, I get 12. And now when I do the negative 1 times the negative 12, and again, that's this negative 1 times that negative 1 times this positive 12, I get a negative 12. And that gives me that 0 remainder I was after. So what that tells me is I now have a 12, a negative 8x, a negative 3x squared, and a positive 2x cubed. Okay, so I know one factor. Let me highlight that factor so I don't lose him. Okay, I know that one factor is going to be, and I'll just write it over here, x plus 1 I know another factor is 2x cubed minus 3x squared minus 8x plus 12. So now the next thing that I want to do is I would like to continue with this because I would like to factor this one even further. So the idea is, can we factor that a little bit further? So what I want to do is I want to think about some of those other factors, okay? So we tried the plus or minus ones. We found one that worked. Now I want to continue with the highlighted factor right here. And the next factor I want to try is 2. So sorry about that, is x equals 2 a 0 of my 2x cubed minus 3x squared minus 8x plus 12. So we're going to try it out. Let's plug into this. So if I plug 2 in, I get 2 times something cubed minus 3 times something squared minus 8 times something plus 12. I'm plugging 2 in. When I do this out, I'm going to get, let's see, I'm going to get 16 minus 12 minus 16 plus 12. And those actually work out really nicely. This equals 0. What this now tells me is x minus 2 is a factor of 2x cubed minus 3x squared minus 8x plus 12. So now that I know it's a factor, basically what I'm saying is this expression will equal this expression times another factor. And the way I'm going to find this is I'm going to use synthetic division again. So I'm going to set it up right here. So let's use synthetic division on this one. So I know that 2 is my 0 because I got it from x minus 2. So remember, again, the signs have to change for the zeros. And now my coefficients are 2, -3, -8, and 12. So when I set this up, we're going to do the same thing we did in the process for synthetic division. These numbers get multiplied together. That's going to give me a 4. I'm now going to add that column, which will give me a 1. I now multiply these numbers together, and that gets me a 2. Add that column, and it gets me -6. Multiply these two numbers together to get me -12. And when I add that column, I get the 0 I want. So now what I know is I have got -6, +x, and 2x squared as the next factor. So if you're keeping track, we have found that x minus 2 is a factor of my original problem, and we also found that x plus 1 is a factor of my original problem. Now the only question is, can I factor the 2x squared plus x minus 6? Well, you could continue to use guess and check. You could keep going, or you can use any method of factoring you want on this. So if I'm factoring 2x squared plus x minus 6, I'm going to just factor this the old-fashioned way. I'm going to look at this guy, and I'm going to break him up, and I'm going to see if I can get lucky with some guessing and checking on this, okay? So I'm going to use a factor of 2 here and a factor of -3 on this one, because the -3 times the 2 gets me -6. The 2x times x gets me 2x squared. So I am just going to double check this to make sure this works. So guessing and checking. The middle terms give me a -3x and a +4x, and that gives me the x I need. So these are the other factors we are looking for. So now if we go back and we collect all of our factors, all right, going back to the beginning, all right, let me just write this down. We've got x plus 1, that was our first factor, and x minus 2 is our second factor, and then we found these two. So the final factors for this guy are going to be x plus 1, x minus 2, 2x minus 3, and x plus 2. And those are the factors when we go and we factor this expression out completely. Oop, I missed that guy. We factor this expression out completely. So let's just copy that whole thing. right? So this is it. These guys are the factors of f of x. This particular section is kind of time consuming. I'm not going to lie. There's a lot of guess and check involved. There's a lot of synthetic division. So before you attempt any of these, make sure you're comfortable with the idea of synthetic division. And then once you know synthetic division, we're just going to keep trying all the different factors until we find the ones that work. I hope that's a clear explanation of what's going on for this particular video. If you guys have any questions at all, please reach out, email me. We'll set up a time where we can talk. Again, this one's a little intense, so don't be shy. Reach out to me if you need anything. Look forward to talking to you guys soon. Take care, everybody.